In today's lesson, toda kuita an experiment where we are going to demonstrate osmosis using a membrane model. Saka we are going to start with this diagram, which is going to be our aid in this lesson. So on this diagram, this is the beginning of the experiment, and this then is the end of the experiment. Saka tinotanga tiine a beaker. Then we have this, like I say, balloon. It's actually the membrane. Then we have some fluid. This is the before. This is the after. Let us write down the method and see what we ought to learn here. Saka our method, chekutanga, we have to fill a whisking tube with a strong sugar or salt solution. Saka we do fill a whisking tube with a strong sugar or salt solution. Saka chekutanga, we have to remember kuti atiri kuti whisking tube iyi property yatinoda from a whisking tube, it's that it's semi-permeable. Kureva kuti it partially allows in the inflow of fluids and also the outflow of fluids. Inotendera this solution kuti ikwanise kupinda kana kuti kubuda. Then kupinda or kubuda now depends on osmosis. Yataka define as the movement, cannot net movement of fluids from a region of high concentration to a region of low concentration. Then it's also important to note that solution here should be strong. And for a strong solution, we have to remember that a strong solution in a low concentration of water, because we are concerned with the concentration of water. Then on our method, secondly, the whisking tube is washed thoroughly with distilled water, dried, and then weighed. Saka, the whisking tube is washed thoroughly with distilled water, dried, and then weighed. So this is what we ought to do. Our whisking tube, after tighter, fill a whisking tube with a strong sugar and salt solution. It is then washed thoroughly with distilled water. Also remembering with distilled water, we are referring loosely to pure H2O. Sizwa takatsanangura kuti imvura inenge isina ma trace elements kana kuti mvura isina ma minerals. And we also explained briefly how distillation occurs. So that the whisking tube is washed thoroughly with distilled water. If we do not use distilled water, we run the risk to contaminate the solution inside the whisking tube, because it's not going to introduce other minerals, other trace elements into the solution. So the distilled water kuitira pass some form of reaction. We dry it, and then we are going to weigh it. The whisking tube is then placed in distilled water. So the whisking tube is then placed in distilled water. And please be sure kuti pese pamunonyora this, you include the point that the water is distilled, because that's kuda kuti tive nema minerals ari mumvura, ma trace elements ari mumvura anoreacta, kureva kuti anocontributa to the solution, the strong salt or sugar solution inenge iri mukati me whisking tube. Then after we have done that, the whisking tube is then weighed again after an hour. Saka, the whisking tube is weighed again after an hour. Let us just summarize zvachiitika panapa. Saka tatanga tiine a whisking tube which is a semi-permeable membrane. Ndobva taisa a strong sugar kana kuti salt solution inside it. Then we should appreciate kuti if it is a strong solution, zvoreva kuti it has a low concentration of water. Saka if osmosis is going to happen after we dip it in distilled water, so that water should be flowing from a region of high concentration to a region of low concentration. Saka at the end of it, we are going to expect the weight of the whisking tube to have increased. Increase with the weight of a whisking tube is evidence of osmosis, kureva kuti mvura yapinda mukati whisking tube. So the results we expect are these. This is just an example of the results we expect. Saka tino expecta, for example, the final mass to be equal to 22.3 grams. But initial mass inofanirwa kuva diki to the final mass. Let us say initial mass is 15.05 grams. Saka this gain in mass yakonzereswa nekupinda kwemvura due to osmosis inge the difference of these two, which is going to be 4.25 grams. Saka this is just a sample of results atinogona kuwana. Chakangokosha kuziva kuti final mass inofanirwa kuva hombe kune initial mass. Hatitombofanirwa kuenzana, it has to be greater. Then taona kuti final mass should be greater. Tofanirwa futi kuziva kuti gain in mass is due to osmosis. Mvura yapinda through osmosis. What is going to be our conclusion? Conclusion yedu, the whisking tube gained mass, showing that water molecules moved from the beaker, where the water molecules are more concentrated, into the whisking tube, where they are less water molecules. Saka we can write it as this. The whisking tube gained mass, showing that water molecules they moved from the beaker where the water molecules have a high concentration into the whisking tube, which has a low water concentration due to the process osmosis. That is going to be our conclusion. Saka, this is the experiment we wanted to do in this class. If you derived any benefit from the lesson, may you consider liking, subscribing, sharing, and also joining if you can. Otherwise, if you want to join our private class doing combined science or level, WhatsApp us on the following number. Thank you and have a nice day.